This is video number 5 from section 1.2, an application problem. The problem reads, let M represent the amount of money in dollars in Stuart's piggy bank at time W weeks since the start of school. An equation for this relationship is given below, and we have M equals negative 10W plus 80. Well, let's try to answer the questions. First question. We have W, we have M. Which one is the independent variable and which is the dependent? Now you could think this through the way we did in the last lesson. It does make sense to say the amount of money he has depends on how much time has passed. It does not make sense to say the amount of time that has passed depends on how much money is in his bank. So just from that, I know that the dependent variable is the money, the M, and the independent variable is the W, the weeks. Even beyond that, we're going to see these let statements all semester long, and I can tell you that every single time they always start by telling you the dependent variable first and the independent variable second. So that's probably something good to remember. A third way to tell is look at the equation. Notice that it fits the y equals mx plus b pattern. It's just that instead of having y, I have m, and instead of having w, I have x. Well, the independent variable is always the x, which means w is independent. The dependent variable is always the y, which means m is dependent. Let's go down to letter B. What is the real-life meaning of the ordered pair 1, 70? Well, in a real-life problem, the key is to figure out what variables these numbers are associated with. Well, we just figured out that the independent variable, the x variable in this problem, is w. So this 1 is a w. The dependent variable is m, so this 70 is an m. That means the 1 is 1 week since the start of school, and the 70 is $70 in his bank. So if I want to give a real-life meaning, we're simply saying after 1 week of school, he has $70 in his bank. Let's go down to letter C. Letter C asks us to complete a table. Well, this is going to require some algebra. If I have a W and I want to know what M is matched with it, I simply go to my equation, and when I get to the W, I'll simply fill in 4. So I have M equals negative 10 times 4 plus 80. And if I work that out, negative 10 times 4 is negative 40, plus 80 is positive 40. So 40 must go in that blank. The other blank, I'm given a 10 for the M, and I want to know what W goes with it. So I'll go to my equation, I'll replace the M with a 10, and this one I'll have to do some algebra. I need to get this W by itself. So I'll subtract 80 on both sides. That leaves me negative 70 equals negative 10W. I'll divide both sides by negative 10. And that gives me W equals 7. We could attach meanings to these pairs as well. This means after 4 weeks, he had $40 in his bank. And after 7 weeks since school started, he had $10 in his bank. Let's go to letter D, which asks us to graph the equation in our graphing calculator. We may have to think about the window that we want to use. So here's the calculator. Looks like our old work is still there. I'm going to go to the y equals area and I will clear that old equation out. And I'm being instructed to graph this new equation. Now the calculator only works with x and y. I had m equals negative 10w plus 80. I have to think of that as y equals negative 10x plus 80. The y and the equals are there, so I'll simply supply the negative 10x plus 80. Now I can try that zoom standard option, but that generally only works if the numbers in the problem are pretty normal and small, because remember, it only gives you 10 in every direction. This is really not that great of a picture of this graph. It's really hard for me to tell what's happening in this early section here. So what I'll do is I'll go to the window and I'll think through the kind of numbers I would want here. Now remember, my x's are my w's in this problem, the weeks. Well, I don't need negative weeks, so I'm going to clear that out. I feel comfortable just starting at 0, which would be the start of school. Going out a maximum of 10 weeks, that seems pretty reasonable. I don't see any need to change that, and counting by ones sounds good. My y values, those are the m's. That's the money. Well, I can't have any negative money, so that seems like something I should change. I'll just change that to 0, the smallest amount of money I could have. And my y maximum, $10, just isn't enough. In some of our examples, we saw numbers like $70. So I better go high. Why don't I go up to $100 to be safe? Now, if I'm going from 0 to 100, I don't want to count by ones. That's a lot of tick marks. I think I'll count by tens so that I can more easily see what's going on. You're always in control of what you want to see. Then hit graph. And now you have a much, much better picture of this linear equation. Let's return to the handout and see what we're going to record for the window. So I'm not being asked to draw the picture, I'm just being asked to write down the window. The way we do that is we open up a bracket, we put the smallest x that we used, which was 0, comma, the biggest x, I believe we went 10 weeks out, and I'll close that bracket, 0 to 10 by, and then same thing for the y. We used 0 for the smallest amount of money. I believe we went to 100. $100 was the highest amount of money we put. And that's how I state the window that I used in the graphing calculator.